Okay, right. So yesterday in the last class we have discussed about IUPAC nomenclature in organic chemistry, and today we are going to discuss about the reactions. So here we discuss about preparation of hydrocarbons and their chemical properties. Okay, so first we start with the preparation of alkanes. So first we start with alkanes. So alkanes are also called saturated hydrocarbons. So saturated hydrocarbons are nothing but there will be all carbon-carbon single bonds. So when all the bonds between the carbon atoms are single bonds, then we call that hydrocarbon as a saturated hydrocarbon. Okay. And they have a general formula, or they will follow a general formula, that is CnH2n plus 2. So for n number of carbons, you will have 2n plus 2 number of hydrogens. And where you can start n from 1, 2, 3 and so on. And they're also called paraffins. Paraffins, as they are less reactive. Comparatively less reactive than unsaturated hydrocarbons, and they are called paraffins. Compared to alkenes, they are less reactive and they are called paraffins. Para means little and little affinity towards reaction. Para means little and affinity. Little affinity towards chemical reactions. So they are less reactive. And in this, when you start n equals to 1, when n equals to 1, the molecular formula of that alkane will be CH4. So here you are going to substitute n equals to 1. So C1H, 2 ones are 2 plus 2, H4. CH4, and this is methane. And already in chemical bonding, we have discussed about the structure of methane. One carbon with 4 hydrogens with 4 covalent bonds. And when you take n equals to 2, n equals to 2, substitute n equals to 2 here. So the formula becomes C2H2n plus 2. 2 to the 4 plus 2. C2H6. And since there are two carbons, the name is ethane. And the structure of ethane will be this way: 2 carbons and 6 hydrogens, where between carbon atoms you have a single bond, and each carbon valency is satisfied with 4 single covalent bonds. Right. So these are the simplest alkanes of this series. So methane is the simplest alkane, and the second alkane is ethane. Now let's see the preparation of alkanes. Preparation of alkanes, that is preparation of methane and ethane. So these two preparations we see. So preparation of methane and preparation of ethane we are going to discuss, and definitely one question will be here. So preparation of methane. So first preparation, it is laboratory method. Laboratory method, and this laboratory method is also called decarboxylation. Decarboxylation reaction. So when a particular name or specific name comes like this, so the reaction will be very, very important. Decarboxylation reaction. In this, first we see preparation of methane, and then we see preparation of ethane. So two reactions. So for the preparation of methane, you will take a compound, that is CH3COONA, which is called sodium acetate. Sodium acetate, this is the common name, and IUPAC name is sodium ethanoate. Sodium ethanoate. So this is IUPAC name, and sodium acetate is the common name. When sodium acetate or sodium ethanoate is heated with sodium hydroxide in presence of calcium oxide, that means this sodium acetate is mixed with sodium hydroxide and calcium hydroxide, and you are heating it. So in this case, this COONA, so this COO is called carboxylic group. This COO is called carboxylic group. So this carboxylic group will be removed. So that's why it is called decarboxylation. So D means whenever this D comes, usually it means it is removing a group. So here what are you removing? Decarboxylation. You are removing this carboxylic acid group. So this part will be removed, and this hydrogen will be added over here. So CH3 and one more hydrogen. CH3 and one more hydrogen becomes CH4, which is nothing but methane. This is nothing but methane. And remaining atoms you can see sodium atoms, carbon atoms and oxygen atoms. So that will give you sodium carbonate. That will give you sodium carbonate. So you will get methane along with sodium carbonate. So this is the preparation of methane. Then we see preparation of ethane. So for this methane, you are taking sodium acetate or sodium ethanoate. For ethane, you will take this compound that is called CH3 CH2 COONA. It is also similar to this compound. The only difference is here you have CH3, that is one carbon. Here you have CH3 CH2. So this is a two carbon group. This is a one carbon group. So same reactants we take almost. Here again we take sodium hydroxide and this is heated with calcium oxide. So same thing happens here also. This carboxylic acid group will be removed and you have CH3 CH2 and here H. So this H will be added over here. So this becomes CH3 bond CH3, nothing but ethane, C2H6, plus the byproduct is same, Na2CO3. So in this way we can prepare methane in this first reaction and this is ethane. So this is laboratory method for the preparation of alkanes. Example, methane and ethane. Right. And remember the name of these reactants here. So this is sodium acetate or sodium ethanoate, this compound. So usually the question will be asked on this reaction, usually most of the times. And this we learn, this also we are learning. So it's better to learn the name of this compound also. So this is called sodium propionate. Propionate, this is common name, and IUPAC name is sodium propanoate. So only propanoate. A slight difference is there in these two names. This is propionate and this is propanoate. Okay, so be careful with the names of these compounds in organic chemistry. Okay, and so in both the reactions, for this decarboxylation, if you see, we are using a mixture of these two, sodium hydroxide and calcium oxide. So this combination, the mixture of sodium hydroxide and calcium hydroxide, this is called soda lime. Soda lime. So this is also one of the important chemical compositions. Okay, a mixture of sodium hydroxide and calcium hydroxide is used as soda lime here. Now in this reaction, sodium hydroxide is taking part in the reaction, but calcium oxide is not taking part in the reaction. Then what is the purpose of taking? In this reaction, calcium oxide acts as a drying agent. It acts as a drying agent. If there is any moisture in the reaction, okay, so it will absorb that moisture so that the reaction takes place smoothly. So that is the purpose of taking calcium oxide here as a drying agent. Calcium oxide is a drying agent. So this is the first preparation of methane and ethane. And second preparation is reduction of alkyl halides. Reduction of alkyl halides. So number 2, reduction of alkyl halides. Nothing but they are halogen compounds. Halide means halogen. Okay, halogen compounds. Okay, organic compounds we take for the preparation of these alkanes. Let's see examples of alkyl halides like CH3Br. CH3 is methyl group, so this is methyl, and this is bromine, so it becomes, the name of this compound is methyl bromide. CH3Br is, this is methyl and this is bromide, this is common name. Reduction means addition of hydrogens, so you are adding hydrogen here, hydrogen atoms you are adding here in presence of a catalyst, a mixture of zinc and mercury. A mixture of zinc and mercury, usually it is called an amalgam, what we learned in metallurgy. Okay, it is an alloy which contains mercury, is called amalgam. So we are using an amalgam as a catalyst over here, so which will activate hydrogen. So in this case what happens, it is like displacement. This bromine will be replaced by hydrogen. Remove this bromine and add hydrogen. Already CH3 is there, you are adding one more hydrogen. It becomes CH4 plus HBr. So the bromine which has come out will react with another hydrogen. So you are taking two hydrogens for the sake of balancing. So here we will get methane as the product. Methane is the product. Similarly, we can prepare ethane also. If you take C2H5I or C2H5Br also you can take. C2H5 is ethyl, like CH3 is methyl. One carbon meth, here two carbons eth. Ethyl, this is iodine, ethyl iodide, plus again similar type of reduction, again you are taking hydrogen, catalyst is same, zinc plus mercury, again here also replacement reaction, iodine is replaced by hydrogen and hydrogen is added here, so C2H5 and one more hydrogen, so it becomes C2H6, it is nothing but ethane, plus, and the iodine which comes out will combine with another hydrogen and forms hydrogen iodide. This way we can prepare methane and ethane in these reactions. Right. So only these two are very important. So which can be asked in a board exam from the preparation of alkanes. And once we see the preparation, we have to learn about the properties also. Properties of alkanes. So first we see physical properties. Physical properties are nothing but their melting points, boiling points, or whether they are soluble in water or not. Okay, so here alkanes, usually lower alkanes, like with one carbon, like methane, ethane, propane, butane, there will be gases. As the number of carbons increases, the density increases and the hydrocarbons will be liquids and then they will be solids. When you have hydrocarbons or alkanes with more than 12 carbons, they will be solids. Below 12 carbons until 8, they will be liquids, and below 8 they will be gases. Okay, so just for an idea, so usually no question comes on this physical properties of alkanes. And at the same time they will have low melting point and boiling points. They will have low melting points and boiling points, and all these hydrocarbons are non-polar. So this is important one. So this is important. All these hydrocarbons like methane, ethane, propane, they are non-polar. So they are insoluble in water. They are insoluble in water. So methane and ethane. Okay, mainly question will be on methane only. So methane does not dissolve in water. What is the reason? Methane does not dissolve in water. What is the reason? The reason is water is polar, but methane is non-polar. So polar can mix, but non-polar cannot mix with polar solvent. Right. So that's why methane is not soluble in water. So this is about physical properties. Now coming to chemical properties. Chemical properties. So in these chemical properties, already I have said the alkenes are comparatively less reactive than alkenes. So remember that alkenes are less reactive than alkenes. Less reactive than alkenes. Why alkanes are less reactive or why alkenes are more reactive than alkanes? There is a difference between alkanes and alkenes. Alkanes will have only carbon-carbon single bonds, but alkenes will have double bonds. So this double bond is the reason for the more reactivity. Because it has a double bond, it can easily participate in the reaction. Okay, so we'll see the reactions of alkenes later. So first we see what type of reactions that alkenes undergo. So there are many types of reactions that alkenes undergo, but we discuss only two types of reactions. What are those two types of reactions? One is substitution reaction. Substitution reaction. Substitution is this reaction is nothing but replacement reaction or displacement reaction. So one hydrogen atom of an alkane is replaced by another atom, or it can be another group also sometimes, but here we are talking about one atom of hydrogen of an alkane will be replaced by another atom. Another atom means another element, another atom of another element. Okay, that is called substitution. So example, we see chlorination of alkanes. So in this, what happens? Hydrogen atom is replaced by chlorine atoms. We'll see one example. So first understand the definition. What is substitution? Hydrogen atoms of alkanes are replaced by another element. Okay, and chlorination. What is chlorination? Hydrogen atoms of an alkane are replaced by chlorine atoms. So particularly chlorine atom. So that's why it is called chlorination. So we have only one example with chlorine, right? So we'll see the reaction of chlorination. So first we see with methane, chlorination of methane. CH4 plus chlorine. So usually this reaction takes place under UV light, or it can be sunlight, or it can be a temperature around 450 degrees Celsius. Okay, any one condition, either UV light, or it can be sunlight, or 450 degrees Celsius. So why this is? This is the condition for this reaction to take part. Now in this you have CH4. Now what is happening? Hydrogen atom will be replaced by chlorine. I have 4 hydrogens. So remove one hydrogen. When you remove one hydrogen, it becomes CH3. So if you see the diagram of methane, I have 4 hydrogens. Now what are you supposed to do? Remove this one hydrogen and put chlorine. So this is the replacement reaction. This is called replacement reaction. So now what happened? When you replace hydrogen with chlorine, this becomes CH3Cl. Now the chlorine, the hydrogen which came out will react with another chlorine atom, Cl2 you are taking. So it forms HCl. HCl. And whether the reaction stops here, the reaction does not stop here. Okay, so reaction does not stop here. It is a chain reaction, stepwise. Okay, one hydrogen is replaced by chlorine, but you have three more hydrogens. So in the second step, another hydrogen also will be replaced by chlorine. So now you remove this hydrogen and put chlorine here. So second step, in the second step, under same conditions, what is the product? This is CH2Cl2. CH2Cl2. So stepwise the reaction goes on now. So whether the reaction stops here, the reaction does not stop here also. Until all four hydrogens are replaced by chlorine, the reaction continues. So here also again, third step, this hydrogen is replaced with chlorine. So now this CH2Cl2 plus chlorine under same conditions, what does it give? CHCCl3. CHCl3. CHCl3 plus HCl. The byproduct is same because one hydrogen is coming out. And last step, still one more hydrogen is there. So one hydrogen also replaced by chlorine. So CHCl3 plus Cl2 gives CCl4 plus HCl. So finally the product is carbon tetrachloride. You are starting from methane and the end product is carbon tetrachloride. Because there are four hydrogens, there will be four replacement reactions. So four steps are there. Okay. Now this is for methane. Because you have four hydrogens, there will be four steps here. Okay. And the second one is ethane. Ethane has 6 hydrogens. But how many steps will be there? 6 steps will be there. But we are not writing stepwise here. We are directly writing C2H6 plus 6Cl2 under same conditions. It will give you C2Cl6 plus 6 times HCl. So usually the question is based on methane most of the times. Question in the board exam is mainly based on methane only. Okay, so usually the question on ethane does not come. Okay, but still you have to learn that. It's better to learn it. Right, so this is about chlorination or substitution of hydrocarbons. Substitution reaction of hydrocarbons. We have done chlorination. And second type of reaction is oxidation. Second type of reaction is oxidation. So oxidation is nothing but combustion here. We are talking about combustion of hydrocarbons. Okay, hydrocarbons have good calorific value. When they are burnt, they can give you large amount of heat energy. So that's why hydrocarbons like methane, they can be used as fuels. Okay, methane is nothing but, we are calling it as compressed natural gas. And when you burn methane, what is the advantage of methane as a fuel? When you burn methane, in presence of oxygen, it gives carbon dioxide plus water. Okay, so comparatively will get less pollutants. Okay, when you burn methane. So methane can be considered as an ideal fuel because it does not cause, or it causes very less pollution. Very less pollution the methane causes. Right, so this is about the reactions of methane. Only two types of reactions we are learning from alkanes, that is methane and ethane, and those reactions are substitution, that is substitution with chlorine, that is called chlorination, and this is oxidation. Right. So this is saturated or alkenes. So next we are going to start with alkenes. Alkenes. Already we have discussed about this. They will have at least one carbon-carbon double bond. They have a general formula CnH2n, and N starts from 2. So least number of carbons in alkene is 2. That means this is the simplest alkene. 2 carbons are there, eth, and these are enes. So this is ethene. C2H4 is ethene, and its structure will be like this: C double bond C and 4 hydrogens. 4 hydrogens. So this is a branched structure of ethene. And these alkenes are also called olefins. They are also called olefins because they form oil-like compounds. Oil-like substances or oil-like compounds. So alkenes are also named as, or they are also called olefins. They are also called olefins. Right. So let us see the preparation of alkenes. Preparation of alkenes, that is ethene. We are going to discuss about only ethene, preparation of ethene. Preparation of ethene. First, laboratory method, that is dehydration. Dehydration of ethyl alcohol. Ethyl alcohol. D means removal. What are we removing here? Hydro. You are removing water. Dehydration means you are removing chemically combined water molecule. So that's why it is called dehydration. Dehydration of what? Ethyl alcohol. So ethyl alcohol's formula is C2H5OH. So this is ethyl alcohol. Ethyl alcohol. IUPAC name is ethanol. Okay, ethanol. IUPAC name. So you are doing dehydration. So for dehydration of a substance, you have to use a dehydrating agent. Here the dehydrating agent what we are using is sulfuric acid. Okay, already we know that concentrated sulfuric acid is a good dehydrating agent. We learn in sulfuric acid lesson. This is at a temperature 170 degrees Celsius. So in this case what happens? Water molecule will be removed. Okay, water molecule will be separated, means H2O will be separated. You remove 2 hydrogens and 1 oxygen. Okay, you have 6 hydrogens, remove 2 hydrogens, becomes H4, 1 oxygen is removed. So what is left with here? It is left with C2H4. The C2H4 is nothing but ethene. And ethene is the IUPAC name, and it has a common name also. Okay, ethylene is the common name. Okay, the IUPAC name I am writing in brackets, and the other name is common name. Right. So one preparation of ethene, that is from dehydration of ethyl alcohol, and the second one is dehydrohalogenation. Dehydrohalogenation. So in D again we are removing. What are we removing? Hydro. Hydro means hydrogen. Halogen means halogen. You are removing hydrogen atom and halogen atom. Both the atoms you are removing from, or dehydrohalogenation of alkyl halide. Alkyl halide. So alkyl halide, again it is a compound of halogen. Like if you take a compound like C2H5Br, so this is ethyl bromide. Ethyl bromide, and this is heated with potassium hydroxide. Okay, it is boiled or heated with potassium hydroxide, but it should be alcoholic. Alcoholic potassium hydroxide. So then it forms C2H4. So same thing you are doing here, removing hydrogen and halogen. You are removing one hydrogen and you are removing bromine. Out of 5 hydrogens, if you remove one hydrogen and bromine is removed, you are left with C2H4. The C2H4 is ethene or ethylene. Okay, so along with that, the byproducts will be potassium bromide plus H2O. So this is how we prepare ethene in these two reactions. One is dehydration and the other one is dehydrohalogenation. So when you have a specific name for the reaction, you have to take it as very, very important. Whether it is dehydration or whether it is dehydrohalogenation, a specific name is given for that reaction. So definitely there will be one question on the preparation of alkene. Every year you can see there is a question either on dehydration or dehydrohalogenation for the preparation of ethene. So these are the preparations of ethene. Then we see properties of ethene. And here ethene has a double bond, nothing but alkene. Usually the compounds having double bonds will be more reactive. Okay? And ethene has a double bond. Since it has a double bond, ethene undergoes or any alkene undergoes addition reaction. So now it is addition reaction, just adding new atoms. You are not replacing anything there. You are just adding new atoms. You are adding new elements to the ethene. Okay, or alkene. So that's why it is called addition reaction. Example, first one, hydrogenation. So hydrogenation is nothing but adding hydrogens. You are not replacing anything. You are not replacing any element. You are just putting more hydrogens on ethene. Like if you take ethene, CH2 double bond CH2, or you can write C2H4 plus hydrogen. Because you are adding hydrogen, it is called hydrogenation. So it is also very, very important. In presence of catalyst nickel and temperature 300 degrees Celsius. Okay, the catalyst is very important. You have to remember the catalyst. What is the catalyst used in hydrogenation? Nickel is the catalyst used in hydrogenation. So now you are going to remove one bond and adding hydrogens. Okay, when you remove one bond here from these two carbon atoms, you will add one hydrogen here, one hydrogen here. So it becomes CH3 bond CH3. So this is ethane. Okay, so this is the conversion of ethene to ethane. So that means we can convert unsaturated hydrocarbons to saturated hydrocarbons by this reaction. What is that reaction called? Hydrogenation. Hydrogenation of ethene gives ethane, or hydrogenation of unsaturated hydrocarbons will give you saturated hydrocarbons. Okay, so this is hydrogenation of ethene. So this comes under addition reaction. And another example of addition reaction, that is chlorination. This chlorination also addition reaction only. Chlorination. In hydrogenation you will add hydrogen atoms. Now in this chlorination you will add chlorine atoms. That's it. So if you take CH2 double bond CH2, that is ethene plus chlorine Cl2, right? So here you have to take a solvent, carbon tetrachloride. So that acts as a solvent here. Same thing happens here. So you have CH2 double bond CH2. What are you going to do? You have double bond over here. So you remove one bond. When you remove one bond, the carbon's balance is not satisfied. So to satisfy that, you will put one chlorine here and another chlorine here. So now this becomes 1, 2 dichloro, 2 carbons are there, it's a single bond N. Okay, 1, 2 dichloroethane. When you know IUPAC nomenclature, it will be easier to name it. Right. So this is when you take chlorine, it is called chlorination. The same thing we can do with bromine. So that will be named as bromination. Bromination. So instead of chlorine, you will take bromine. CH2 double bond CH2 plus bromine. Same solvent we take. Okay, so we are not taking water because this is an organic compound. Organic compound, ethene does not dissolve in water. So you are taking organic solvent only. So same thing happens here. CH2 double bond CH2 is there. So when you add bromine, you will remove one bond and you will add one bromine here, one bromine here. So every time you have to see that carbon is having 4 bonds. So now this becomes 1, 2 dibromoethane. Dibromoethane. Now this can be taken as test for unsaturation. Bromination reaction can be taken as test for unsaturation because alkanes will not react with bromine this way, but alkenes they react with bromine and they will give you a colorless compound. But bromine has a color, reddish brown color. So when you pass ethene or any alkene or any unsaturated gas, any unsaturated compound through bromine gas, the color of bromine will be decolorized. Okay, we take bromine water. Okay, so it will be decolorized. Okay, so this can be taken as test for unsaturation because unsaturated hydrocarbons will decolorize bromine. Unsaturated hydrocarbons, even alkynes can also decolorize bromine. So that's why we can consider or take this as test for unsaturation. Okay, now so this is about alkenes, preparations and properties, and alkenes like ethene, or it is also called ethylene or ethylene. So this is used in artificial ripening of the fruits, and it is also used in making polymers like polythene bags. We use plastic covers. Okay, polythene or polymers. Polythene is nothing but polyethene, but it is a compound which is obtained from ethene. Okay, very long, very big compound that is called polyethene, or we can call it as polythene. Right, so these are some uses of ethene or ethylene, and next we go with alkynes. Alkynes also unsaturated hydrocarbons with a general formula CnH2n minus 2. For n number of carbons, you will have 2n minus 2 hydrogens, and there will be at least one carbon-carbon triple bond. And here also N starts from 2, because with single carbon you cannot show carbon triple bond carbon. At least 2 carbons should be there. So the simplest alkene will be with 2 carbons, that is C2H2. If you substitute N equals to 2, in this case you will get C2H2, and its name is ethine, and its structure will be like this: C triple bond C, C bond H, and C bond H. Ethine is IUPAC name, and we have a common name also, that is acetylene or acetylene. Acetylene or acetylene is the common name of ethine. Right. So let's see the preparation of alkynes. Here also we see only 2 methods. One is from calcium carbide. From calcium carbide. Calcium carbide is CaC2. Okay. So in the market we just simply call it as carbide. Okay. But this is chemically called calcium carbide. Calcium carbide plus. With water it can react easily. With water it reacts easily to directly give ethine, acetylene. You will get ethine. So very simple reaction. Just taking a piece of carbide and add H2O, it will produce acetylene gas. It's a very easy reaction, simple reaction. Okay, along with that you will get calcium hydroxide, CaOH twice. CaOH twice. So this is one of the preparations of acetylene or ethine. Right. So next one, second preparation, similar to ethene, that is dehydrohalogenation. Dehydrohalogenation. So D, removal of hydrogen and halogen. So in this case you are going to take a compound like this, HBr and Br here, H here. So if you know IUPAC nomenclature, the name of this compound will be 1,2 dibromo, 1,2 dibromo ethane. 1,2 dibromo ethane. Already we have prepared this compound somewhere, if you remember. 1,2 dibromo ethane, 1,2 dichloroethane, already we have prepared somewhere just before this. And here we are going to heat this with alcoholic KOH. Alcoholic KOH means it is dissolved in alcohol. Right? We cannot take water as a solvent for this. You are taking alcohol as a solvent for this particular reaction. And boil it or heat it. So this HBr is removed and this HBr is removed. So what will you get? CH triple bond CH. So simply you will remove this HBr and put a bond here. You remove HBr here and put a bond here. That's it. You will get that CH triple bond CH. That is ethine. Okay. So this is ethine or acetylene. And the byproducts will be 2 KBr plus 2 H2O. To balance this, we write 2 KOH there. So these are the two preparations of ethine or acetylene. Acetylene or ethine is prepared in these two methods. Now let's see the reactions of ethine. The reactions of ethine simply similar to ethene, because ethane also has unsaturation, means triple bond is there. So this will also undergo addition reactions. Ethine undergoes addition reactions. Addition reactions. Okay. So first addition reaction. In ethene, what we have done, for ethane also we do the same. First one is hydrogenation. Hydrogenation of ethyne or acetylene. Ethyne is also called acetylene. So what is the formula? CH triple bond CH. Hydrogenation. You're adding hydrogen. What is the condition? Catalyst is nickel and temperature is 300 degrees Celsius. Okay. So now what are you going to do? You are going to is addition reaction. Whenever you do addition reaction, you have to remove one bond from multiple bonds. Okay. It is a triple bond. So you have to remove one bond from here. See, for example, you have CH triple bond CH. What am I going to do here? I am going to remove one bond. So when you remove one bond between these two carbons, both the carbons will have vacant bonds. So now what are you adding? Hydrogen you are adding. So one hydrogen here, one hydrogen here. If you see it properly, this is nothing but ethene. This is nothing but ethene. CH2 double bond CH2. It is nothing but ethene. Same. Now since you have still one double bond, this can be carried forward. Means the reaction can go further under same conditions in presence of nickel and 300 degrees Celsius. Now it is nothing but ethene. Ethene plus hydrogen. Ethene plus hydrogen. So again you will get CH3 bond CH3. In the second step you will get ethane. It is ethane. So that means this is ethyne triple bond. Ethyne can be converted to ethene and ethene can be converted to ethane. So this is very important because this is conversion of unsaturated hydrocarbon to saturated hydrocarbon. Okay, so this is about hydrogenation. Now similarly, the second type of addition reaction that ethyne takes part is chlorination. Chlorination of ethyne. Chlorination of ethyne. Chlorination is nothing but adding chlorine. So I have CH triple bond CH plus chlorine. Same conditions, just like alkene, we are taking carbon tetrachloride as a solvent. So what are you going to do? Remove one bond and add chlorine atoms here. So I have CH triple bond CH. So what should I do? Remove one bond and one chlorine here, one chlorine here. So that every time the carbon's valency is 4. Now still there is a double bond. So again one more chlorine atom, right? Sorry, another chlorine molecule. Another chlorine molecule plus Cl2. Now this double bond also means one of these double bond will be removed and it becomes single bond. Already 2 chlorines are here and you are going to add 2 more chlorines here. So the name of this compound will be 1122 tetrachloroethane. 4 chlorines are there, so tetrachloro, 2 carbons, it's single bond N. So this is 1, 2, 2 tetrachloroethane. Okay, right. So this is chlorination. Similar way we can do bromination. CH triple bond CH plus bromine under the same solvent. Bromine also dissolved in CCl4 only because it is acting as solvent here. Now I have CH triple bond CH. What am I doing here? Out of these 3 bonds, remove one bond and put one bromine here, one bromine here. Still one double bond is there. Then the second step, next step, you remove that one bond and now this becomes CH bond CH. Here one bromine, here one bromine, here one bromine and here one bromine. So this will be 1122 tetrabromoethane. 1, 1, 2, 2 tetrabromoethane. Right, so these are the reactions of alkynes, that is ethyne. So next one is about the functional groups. Okay, functional groups, that is alcoholic group, alcohols. Alcohols are nothing but they are hydroxy derivatives. Hydroxy derivatives of alkanes. What is the meaning of hydroxy derivatives of alkanes? When you take an alkane, for example, it is methane. Methane has 4 hydrogens. Now here hydroxy derivative means it is derived from alkane. Derived from alkane. How? By replacing one hydrogen with hydroxy group. You are replacing one hydrogen by hydroxy group. You are deriving that compound. So that is called alcohol. So that's why it is called hydroxy derivative of alkanes. Alcohols are hydroxy derivatives. So this is the simplest alcohol, that is called methanol. Okay, already we have learned in IUPAC nomenclature. One carbon meth, single bonds ane, alcoholic group is there, so OL, methanol. If you have this type, means with 2 carbons you have hydrogen, 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 hydrogen. This is ethane. In this ethane, one hydrogen is replaced with OH. So now this becomes ethanol. 2 carbons eth, single bond ane, and alcoholic group OL. So this is ethanol. So these two are the simplest alcohols. Okay, one is methanol and the other one is ethanol. Right. So the general formula for alcohols can be written as CN H2N plus 1 OH, where N can start from 1, 2, 3 and so on. So this is the general formula, and this is the first member of alcohol homologous series. Okay, for alcohols also we can write homologous series using this general formula. Okay, where N starts from 1. So this is the definition of alcohols, and these two are the first 2 alcohols of alcohol homologous series. Next, preparation. Preparation of alcohols. Okay, preparation of alcohols. So first one is from alkyl halides. Alkyl halides. Okay, from alkyl halides. Only one preparation we are going to see. Alkyl halide like CH3Br, and this is heated with aqueous KOH. Similar reaction we have done somewhere. Okay, so here you are taking CH3Br KOH and boil this. So now you will get CH3OH. So nothing but this bromine is replaced by OH. Remove bromine and put OH. Nothing but double decomposition. OH comes here, bromine goes there. So you will get KOH. Sorry, it becomes KBr. So this is methanol. Methanol. This is IUPAC name, or this is methyl and this is alcoholic group. So common name is methyl alcohol. Methyl alcohol. Similarly, when you take C2H5I, so this is ethyl iodide. So with this already we have done somewhere. Ethyl iodide plus KOH aqueous on heating or boiling gives C2H5OH. Same thing, iodine is replaced by OH. So this is ethyl alcohol plus Ki. So this is ethyl alcohol. Ethyl alcohol, and IUPAC name is ethanol. Ethanol. This is IUPAC name. So this is the preparation of alcohols. Only one method we are learning here. Right, so this is preparation of alcohol. And hydrolysis of ethene also gives alcohol. Hydrolysis of ethene means you will take C2H4 plus water in presence of acid like H2SO4 will give you C2H5OH. So this is also another method of preparation, but this is not so important. So first method is very important, that is from alkyl halides. From alkyl halides we prepare alcohols, that is important. Then, so next one is alcohols are water soluble, and let's see the chemical properties. Chemical properties of alcohols. Okay, particularly we are talking about ethyl alcohol. Mainly we talk about ethyl alcohol. So C2H5OH. So this is ethyl alcohol. So this ethyl alcohol is slightly acidic in nature. So since it is acidic in nature, it can react with metals. When an acidic substance reacts with metals, it will produce hydrogen gas. Along with that, this hydrogen is replaced by sodium. So hydrogen comes out as hydrogen and sodium comes here. So this is the product you get, C2H5ONA. So this is called sodium ethoxide. Sodium ethoxide. So this is one reaction. And second reaction is dehydration. Second reaction is dehydration. So this dehydration already we have done for the preparation of alkenes or ethene. So C2H5OH, when it is heated with concentrated sulfuric acid H2SO4 at 170 degrees Celsius, this gives C2H4 plus H2. So water molecule is separated from this C2H5OH. So C2H5OH, you remove H2O. So what is left? C2H6. So this is ethene. So already this is nothing but preparation of ethene, which we have already done. Third one, this is very, very important one. So this is called esterification reaction. Esterification reaction. So in this esterification reaction, this is very, very important reaction. Almost every year question comes on this esterification. So in this, you will take acetic acid or carboxylic acid plus ethyl alcohol C2H5OH, and this will be heated in presence of sulfuric acid. Okay, so this mixture, so this is acetic acid, this is acetic acid, and this is ethyl alcohol. Okay, so this mixture will be heated in presence of sulfuric acid. So when this mixture is heated in presence of sulfuric acid, it gives a product like from here H is removed and from here OH is removed. So remaining part CH3COO and C2H5. So this will combine to form CH3COO C2H5. So OH is removed from here and OH is removed from here, and then remaining you will write. And this H and OH will form water molecule. Okay, so this is a compound called ester. Okay, so commonly the general name of that compound is ester, or it is called ethyl acetate. Ethyl acetate, it has a sweet smell. It has a sweet smell. So that's why these esters are used in the making of perfumes. Okay, esters are used in the making of perfumes. So this is very, very important reaction. Esterification is definitely 99% it will appear in the board exam paper. That is esterification. Okay, so here sulfuric acid acts as a dehydrating agent again, because it is removing water. This water is absorbed by sulfuric acid. So what is the purpose of sulfuric acid? Dehydration. It is removing water, chemically combined water molecules. So this is about alcohols, and usually these alcohols are prepared by fermentation process also. Okay, like wines, and other drinks contain alcohols. Okay, so that is made by fermentation process. Okay, then last one, carboxylic acids. Carboxylic acids, last topic of this lesson. Carboxylic acids, these will have COOH group. COOH, we can write like this, or we can write C double bond O OH here. So this will be attached to some group. So this is carboxylic acid group. So simplest carboxylic acid group is HCOOH, or we can write it as HCOOH. So this is called formic acid. This is common name. IUPAC name, one carbon is there. So methane carboxylic acid will have secondary suffix oic acid. So this is methanoic acid. And the second one is CH3 bond C double bond O OH, or we can write it as CH3COOH. We know this. This is acetic acid. Common name is acetic acid, or IUPAC name is ethanoic acid. So I am writing IUPAC names in the brackets, and the other one is common names. Right. So this acetic acid in the pure form, when you solidify or when you freeze it, it will form ice-like crystals. So that's why acetic acid is also called glacial acetic acid, but in the form of, when you take pure acetic acid and in the solid form. Right. So next we have preparations. We don't have, we have only reactions. Reactions of acetic acid. Preparations we are not doing, it is not there in the syllabus. Okay, reactions of acetic acid only we are doing. Reactions of acetic acid. Since it is an acid, obviously it reacts with the base. Okay, acid usually reacts with the base to form salt plus water. Okay, let's see. If you take CH3COOH plus NaOH, NaOH is a base. Right, so here H is replaced by sodium. So what will you get? CH3COONA. So this is sodium acetate plus water. So this is salt. Sodium acetate is the salt. So similarly, it can react with carbonate to give carbon dioxide. It can react with metal to give hydrogen gas, like CH3COOH. Plus, if you take any metal like sodium, calcium, anything, it will give you salt, that is CH3CONA, again sodium acetate plus hydrogen gas. So this hydrogen comes out and sodium takes the place of hydrogen. So to balance the reaction, 2 here, 2 here and 2 here. And third one again, esterification. So esterification is common in both the compounds, that is alcohols and carboxylic acids. So since we are talking about acetic acid, so again acetic acid CH3COOH plus ethyl alcohol in presence of sulfuric acid on heating gives a compound called ester CH3COOC2H5, which has a sweet smell along with water. So its name is ethyl acetate. Its name is ethyl acetate. Right? So this is about the reactions in organic chemistry. Okay. So in the last class we have discussed some other topics and IUPAC nomenclature, and this is about the chemical reactions like preparations and chemical properties of various compounds. Okay, right. So we end the class for today here. We'll meet in the next class.